Okay, I'm going to try to show you how to use the chain rule to find derivatives the way that I do it, and then another way that's also equally useful. So here's my function. It's y equals a giant quantity a giant quantity to the fourth, and then f of g of 3x squared plus 5 over 8. So it's a pretty complicated function. Let's see what we can do. My method is to say things like stuff, blah, something, and that thing quite a bit. Mostly I say it in my head, unless I'm explaining an example, then I'll say it out loud. So I look at this problem and I see something to the fourth, right, because that's the biggest outer function. What is that thing? It's f of something, right here. And then what's this something? Well, it's g of something. And then finally we get to a function where I can just take the derivative, and that's my goal. Like, I keep going until I get something where I just can look at it and find the derivative. So, to start with, the derivative of something to the fourth is 4 times that thing cubed times, in parentheses, the derivative of that thing. We put the parentheses there in case there's a product rule or something. The whole derivative needs to get multiplied by this 4 times the thing cubed. Then I'm going to replace the thing with what we're actually dealing with, which is f of g of blah. So, moving on, now I need to multiply by the derivative of f of all this junk. So, let's see. The derivative of f of all this junk is f prime of all this junk. Excuse me. Times, in parentheses again, the derivative of this stuff, g of 3x squared plus 5 over 8. So, moving on, now I need to multiply by that derivative, so I'll need to find it. The derivative of g of all this stuff is g prime of all this stuff times, in parentheses again, the derivative of all this stuff, so the derivative of this. So finally, I will end up with all of this stuff, so I've been chaining it all along, and then times 3x over 4. Really, you get 6x over 8, but you simplify that. So that's how I'll find the derivative. But there's another method which is equally useful, and that is to really break it up. So we're going to decompose this quite a bit. So we look at this function, we see a giant quantity to the fourth, so we say y equals u to the fourth. So y is the dependent variable, and u is the independent variable in this case. And then u, the thing that we're taking to the fourth, is f of something, so we'll call that f of v. So u is dependent, and then v is independent. And then what's v? Well, v is g of something, so what should we call that? We'll call it w. So v is g of w, and then w is finally 3x squared plus 5 over 8. And I can take the derivative of that with respect to x with no problem. So I write down the derivative that I want. I want dy dx, and the way that I will chain that together is I'll find dy du, and then du dv, dv dw, and dw dx. And I'll multiply all of those together. If you've done that correctly, the main dependent variable will be on the top left here, and the main independent variable will be in the bottom right. By main, I mean in the original problem. So let's see. Now I'm going to calculate each of those derivatives, so all 4 of these derivatives. Calculate them. So the derivative of u to the fourth with respect to u is 4u cubed. The derivative of f of v with respect to v is f prime of v, and so on. Finally, I get dw dx is just 3x over 4, and I substitute into the formula that I wrote down before. And really, you don't need to write this formula down if you can just keep track of it in your head. So I have that. The problem here is that I have v's, w's, and u's in my dy dx, and I probably don't want that because I introduced those into the problem. So what I can do is I can back solve kind of, I know what w is equal to, so I can substitute every w I see with this. I know what v is equal to, it's g of w, which I substituted in for, and so on. So what happens is I just go through and replace. So g prime of w becomes g prime of, I replace w with 3x squared plus 5 over 8, and so on and so on, and I end up with the exact same derivative as what I had before. So what I'll do next is make another short video that you can watch for how to evaluate this, but I'm guessing you probably already know how, so you might not need